Welcome back. So, the point of this video is to work on factoring trinomial quadratics where the coefficient of x squared, or the a term, does not equal 1, or doesn't equal -1 either. Factoring these types of quadratics is quite a little bit more involved than factoring the type we've been doing thus far, where a is in fact 1, but it's sufficiently systematic that it's not that big a deal. So, the method I'm going to use in this video is the X box method. The X comes from the X pattern thingamajig that we've been using to come up with the factors of a times c that add to b. We're still going to do that. And the box comes from the box pattern that we used way back when we first started multiplying binomials together. The box looked like this, and if you had a binomial x plus 2 times 2x minus 1, and you were going to multiply that together, then you used it like a Punnett square, and 2x times x is 2x squared, and 2x times 2 is 4x, and -1 times x is -x, and -1 times 2 is -2. That, and then you combine like terms and zippity-doo-dah. It's this box pattern. That is the box part. So, on with the game. So, the first quadratic I've got is 3x squared plus 13x minus 10, and we're going to factor it. So, let's see. The x part, a times c and b. 3 times -10 is -30, and b is 13. Let's see, the factors of -30 that add to 13 would be 15 and -2. Yep. So now if the a term was 1, we'd be done. Only it isn't, unfortunately. So now with this box, and the box just organizes a place to keep track of everything being the pieces. So what we really want are the parts outside of the box, which were the binomials that were multiplied together to get the inside right here. And at the moment, what we have is the insides and want the outsides. So what we've got is the leading term right there, which is 3x squared, and we've got the last term, or the constant term, which is -10, and then the part that is played with the x factor gizmo right there is these terms on the sides provide the factors of x that are added together. So this would be 15x, and that would be -2x. So when we got, if we had the binomial terms up there, then these two multiplied together would give 3x squared, and those two multiplied together would be -2x, and so on. So now the trick is to this is GCF City. So the trick is to get the GCF in both columns and both rows, and factor the GCF out and write them right there, right there, right there, and right there, and then we've got the terms of the binomial that would have been multiplied together to get all this mess. Okay, so the GCF between 3x squared and 15x would be 3x. And the GCF between negative 2x and negative 10 would be negative 2. And the GCF between 3x squared and negative 2x would be x. And the GCF between 15x and negative 10 would be 5. Now, a point of caution. When factoring these kinds of problems, you got to be awake with the negative signs in a big way. So, kind of a way to look at that is as you were factoring this column right here, and you took the term out and crossed over that negative sign right there. That makes the term in the outside be negative. This one you crossed over a positive sign, positive, crossed over a positive sign, positive, crossed over a positive sign, positive. But the thing that you want to be aware of to double check all that is when you put these together, then kind of be making sure that that term times that term is equal to that one, and that term times that one term is equal to that one, and so on all the way through the problem. Because now we're done. We can then take the outsides and write down the terms that are the factors of 3x squared minus 13x minus 10, which would be x plus 5, which comes from right there, and this other one, which is 3x minus 2, which comes from right there, and we are done. Let's see, 3x times x times 3x is 3x squared. Negative 2x, 15x added together is 13x, and 5 times negative 2 is negative 10. So we get right back where we started from. So that worked. Let's do one more. I'm sure you can't wait. Let's see, this one is 9x squared plus 35x minus 4. Okay, X pattern Houdingus. 9 times A times C. 9 times negative 4 is negative 36, and the B term is 35. Let's see, the factors of negative 36 that add to 35 would be 36 and negative 1. So then we're going to now set up the box part. Crap. Man, I was shooting for a different color and I missed. Alrighty, leading term 9x squared goes right there. Constant term negative 4 goes right there. And 36x and negative x, or negative 1x if you want. And by the way, it doesn't matter whether, oh geez, nice 36x over there. 36x and negative x. It doesn't matter if the negative x goes there and the 36x goes there. It will work either way. So now it's GCF time. And let's see, the greatest common factor right here between 9 and 36 would be 3. 9 won't go into 36, honey. 3. The boss lady's over there helping me out. Oh, well, maybe she's right. 4 times 9 is 36. Oh God, she's always right. That's a lesson for the boys. The boss lady is always right. So, the greatest common factor between negative x and negative 4, there's a good one for you. I'm sure the boss lady can figure that one out too. But that would be negative 1. Then on the other side, the greatest common factor between 9x squared and negative x would be x, and the greatest common factor between 36x and negative 4 would be 9. And we're done. So we would be x plus 9. What? Shit. She's right again. That would be 4. I had that 9 in my head. The greatest common factor between 36x and negative 4 would be 4. And now we're done. X plus 4. The amazing power of an agile mind. She's over there watching TV and not paying any attention to me and still keeps track of all that. So x plus 4 from right there and 9x minus 1 from right there. And God willing and the creek don't rise, that will work. I better check that out. X times 9x is 9x squared negative x plus 36x minus 4. Combine like terms right there. 9x squared plus 35x minus 4. We got it back. Hallelujah. So, in summary, when you get these quadratics where the coefficient of x squared, or the a term, is not 1, one method of factoring them is the x box method. And the x pattern is exactly the same as we have used in the past, where you take the factors of a times c that add to b to get the sides of the x, which then are used in the box, and the inside of the box becomes the leading term, the constant term, and then the sides of the x pattern have the terms of x that would be combined together in like terms if one were multiplying. And then you take the greatest common factor out of the columns and the rows, and then the terms that appear on the outside are the binomials that are multiplied together, which are the factors of the quadratic. And we're done. Take care of them. Bye-bye now.